Hey everybody, this is Larry. This is me going Q3 of the Leetcode weekly contest for 39 sum of k subarrays with length at least m. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one I thought is kind of hard. I was able to get it, but I had 5 wrong answers. But some of it is just because I tried using Java. The TLDR is that Leetcode has really bad timing on TLE, on time limit exceeded. So I tried a couple of different things and it didn't work. But there's a lot to be learned about this problem. Just to be clear, I'm going to go kind of slow in this video because I really want people to learn from this, because I think this is a very interesting problem to kind of learn from some of the techniques there. And there are a couple of techniques that we'll talk about and go over. So if you struggle with dynamic programming, and this is kind of a little bit more advanced, though apparently it's only a 5-pointer these days, I think it's very interesting and definitely something that everyone can go over. That said, this video is very long, as you can see. I mean, as of this recording, it doesn't count here, but it's a couple of hours long, right? The live portion, I actually kind of go over it, and even though I solved this during the contest in only about half an hour, some of it just wasting time. Near the end, though, you see me upsolving. I actually end up spending maybe 2 hours to upsolve this problem in different ways and practicing different techniques. I wanted to show it to you because, I don't know, maybe it's interesting, maybe it's not. But the explanation won't be that long, even though I will try to be as deliberate as I can. And it'll be a little bit long, but, you know, it'll be because it'll be worth it. But definitely, you know, this is kind of a difficult topic. Feel free to kind of rewind and watch again, or just come to Discord and ask specific questions. My pet peeve, of course, is that you have to ask specific questions. Don't just say, I don't understand, because, look, this video is long because there's a lot to explain. If you just tell me you don't understand, I'll just be like, watch the video again, right? Anyway, okay. So first of all, the reason why I kind of struggle with the upsolve, and there are a lot of different people did it a different way, is because actually it's kind of funny, right? So the reason why is because I'll show you this, and just to kind of give a little bit of context, this is a dynamic programming problem. Honestly, this is a tricky problem, so I'm not going to go over the dynamic programming problem in this video, or like general dynamic programming ideas in this video. It's more of an advanced video, even though this is only a medium, and the reason is because I don't want to make this longer than it already is. This is already going to be a long video, even just the explanation is very long, but my hope is, like I said, you're already familiar with dynamic programming, but you couldn't figure out how to optimize it enough to get it down, and that's basically the way that I would think about it. Okay, so the first thing I did, honestly, I didn't realize that this at the time, but I did an optimization, right? But yeah, and honestly, I think it should have passed, but that's besides the point. But yeah, so I kind of came up with this immediately, and the idea is actually very, really odd. Actually, I want to go, because I actually have a lot of different solutions, right? So I actually want to go over the really basic one, but I will admit that I actually missed this really basic idea, and that's why I didn't get the optimization very quickly. Is because I missed this idea. But okay, so going over, this is what I would call the simplest, the naivest dynamic programming solution, right? It's just that we have index, we have k left, and the index goes from 0 to n, k left just goes from 0 to k, and it is kind of what it sounds like. You basically go at every index, you ask yourself, do you start a new subsequence or subarray or not, right? So that's all this problem is, right? Is that you ask yourself if you start with the subarray or not, right? And basically it becomes tick no tick, right? You start with 0 to k, or you start with index of 0, the first index, k with the number of k's left, right? If you have no more k's to use, then you return 0 because you can't really add any more number. If you ran out of numbers, that means that k, you still have k left to use. So we return negative infinity because that's not a possible answer. So we just make it negative infinity, right? So this is like I said, a classic tick, no tick. If there's no tick, you just skip this index. You go to the next index, right? Otherwise, you just tick, and this is a for loop, right? You either tick. Oh, I did do a prefix sum here, but you don't really need it for this particular part. And I'm not going to go over prefix sum in this solution, just because, like I said, this is already going to be very long. But suffice to say that this number will give us the sum of the numbers between index and index plus L, not including index plus L. Okay? I'm not going to go over prefix sum at all in this video because it's already very long. So my apologies. I have a lot of prefix sum videos actually, so you should check those out. But yeah, so basically it's just saying, okay, what if, and L is the length, we go, okay, what if we take index plus L, if we take L length where L is at least M, right? So if M is 2, then you try taking from index to index plus 2, index plus 3, index plus 4, dot, 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 right? So like I said, this is a very naive solution. Hopefully y'all understand it. If you don't, then you really need to work on dynamic programming. Yeah. Okay. So what happened next is actually kind of a little bit wonky. I was trying to take advantage of the fact that, well, M could only be 1, 2, or 3, right? So I go, okay, well, oh, this is too slow, right? Let me step back for a second. This is too slow because N is 2000. K could be, I think, 2000 maybe. Yeah, I mean, say 2000. But there's also this for loop that's N. So you're going to have 2000 times 2000 times 2000, which is way too big. So this would time out. I didn't even submit this, right? Other than to check that it would time out. I actually jumped straight to this optimization because I thought that M could be 1, 2, or 3. And basically the state here is similar, but index goes from 0 to N. K left goes from also 0 to K, right? Can contain you just means that I have a subarray going. Keep on using this one, and then M left is just the number left, or the number left requiring M, right? So I kind of got up to this, and the M left. Maybe I should explain the M left a little bit. It's just that you know that you need a subarray of least length M, so this is just the M required left, if you will, right? So for example, if M is equal to 3, then when you take a character, it goes to 2, and then 1, and then 0, and it could go past 0, which is what the can contain you means. But yeah, and honestly, this should have passed, kind of, maybe. It's a little bit tight still, but it should be, roughly speaking, should have passed. Right, because this is 2000, this is 2000, this is up to 4, right? If M is 3, then you have 0, 1, 2, 3, 4. So 4, so this is times 2. So yeah, so okay, so it becomes 4000. Oh, sorry. But the key thing to note is that there's no for loop, so this is O of 1, even if it's an expensive O of 1, right? And what happens here is that, yeah, I mean, it kind of just allows, because the way that I thought about how to get to here is that I thought, okay, maybe we could use the M, and then I added can contain you because you want to be able to do more than M, right? You could have also done M left is equal to negative, but you still have a strict problem of yeah, it just goes too much, right? And actually, in a way, can contain you is just M left is equal to -1, except for you cap M left is at -1 or something like that. So it's actually not times 2 as this looks like, but it still becomes like 5. So you have 4 million, right? 2000 times 2000 is 4 million, times 5 is 20 million, which is a little bit too slow. But this is still a very good optimization to make in general, maybe not for this problem. Because, and then you go over the state, and we could go over the state, which will explain this a little bit better, which is that, okay, if M left is equal to 0 or greater than 0, we have to keep going, right? And we keep going by doing -1, and yeah. Otherwise, and this is commented, right? And you add the number because we have to keep going. We have no choice. We start a new one, right? And when we start a new one, I don't know. Yeah. Yeah, and this is to start a new one. I don't know if that can continue is a good name, but we'll edit it, right? I define this as true. Otherwise, you want to continue the previous streak. Actually, this is kind of wrong, isn't it? Oh, no, this assumes that m left is equal to 0. That's why. So you start a new subarray, and the new subarray, it looks like this. You already used one of the m, which is why you have m minus 1. You use a new k left, or use a new k, so k left minus 1, and you just start. This is just a send no value. I don't know if there's anything to it. Otherwise, this is can continue. Right, so you continue the previous streak, and this is going to be true, and you just keep going, and m stays at 0, right? You could also treat this as like I said, if m is equal to -1 or something. I don't know, right? And then here is now we end the streak, right? So this, if you want to think about it as no tick, this is no tick, and this is tick, but continue the previous streak, and this is tick, but start a new streak, and this is just forced to tick because you have an m left, so you cannot skip, right? There's no tick because you have m left. Again, this is still too slow because you have I don't know, either 20 million or 32 million, depending on how you want to do the math. Both of them are just too slow anyway. So I thought, okay, well, can we get rid of the m left? And that's basically what I did next, right? I got rid of the m left. Index can go from 0 to n. K left can go from 0 to k. Can continue, just the same thing. Can we add to the subarray the previous subarray, right? And this is again tick no tick, right? So tick start a new one, tick continue the previous one, and then no tick. So we don't use it at all, right? So we don't use this number at all. So that's it. And the state is that you can, if you start a new one, you can always continue and add on to the streak. Again, we have to prefix sum here to get the subarray range sum. Here we just take one number, but we take the range, right? And here we just continue not using it. So honestly, this one should have passed because this is just 2,000. This is 2,000. This is 2. So this is at most 8 million, and this should have passed. But Leetcode is silly. It is what it is. And it's even worse than that because after that, I thought, okay, maybe can it do a little bit better? And the answer is maybe. I did it bottoms up. It still times out. I mean, it's still the same kind of complexity, but it just bottoms up. And I had to do a lot of special optimizations, right? Because like you see the if statements instead of using a function, which has a little bit of overhead. So a lot of things like that, and it still wasn't fast enough. So I had to do, and this, if you look at this code and compare it to this code, it is very similar. It's just that, it's just that I converted to bottoms up, right? And yeah, and if you are curious about this, how I make the transition, it is in the live portion later on, so you could skip ahead to see how I kind of do the upsolve part, right? Yeah, it's really far in though, so yeah. And then next, nope, did I skip a place? Yeah, I mean, so yeah, so what happened here is that at the end I did optimize this a little bit more to be correct, but as I said, honestly, yeah, like I did a lot of more specific optimizations to get to AC, but what I did during the contest is that I just converted to Java, and the Java version of this code is good enough. It's not good enough in Python. I needed to do like 4 more optimizations or something like that to make it work. So the same code in Java works. And it is very sad for me because you can see, like I spent a lot of time on these kind of things, right? Okay, but honestly, looking back, and I didn't know this at the time, but looking back, I I jump from here to make this optimization to use mleft and then get rid of mleft and then convert it to bottoms up, right? But it turns out, and I'm going to close those windows, I could have, oops. It turns out that there's another way to optimize, which I didn't know about, and which is why I wanted to make this video, is because, you know, it's actually interesting. So you have this, and then the next thing I would do is write it bottoms up. I know that bottoms up would not be fast enough, but you know, but this is how I rewrote it bottoms up. Again, this looks very similar to this code, so I'm not going to go over the explanations. If you want to, I actually talk about it a little bit more in detail if you skip ahead to the upsolve all the way at the almost at the very end, the last like 20 minutes or so. The upsolve, I actually try to upsolve it using this part. So if you want more details, you know, but this is basically me converting it from here to here during that part. And as I got this allowed me to kind of see the problem a little bit in a different angle. And after I got this, then I asked myself, okay, what does this mean, right? And what this means is that I wrote it out, is that, I wrote it out, and then I looked at the two adjacent. So if you look at the for loops, right? And this is very difficult to see, so I want to put an emphasis on it, right? So if you look at these two for loops, well, best is just you go to, when we do a no tick, then we just fill it out in this way, right? You look at the previous index plus 1 on the DP and you fill it out. Pretty straightforward. This part we kept, right? And then now this part is a for loop. And the way that I wanted to look at it is that, okay, well, if we're going from here, because basically we're going from DP, oh, I did actually make some optimizations here. That's why this looks a little bit, I wanted to do more. Okay, I'll have to explain this anyway then. But yeah, but basically the way that I did was that I wrote out, and let me actually put this back in real quick. And you'll see why in a second, hopefully, or maybe in a couple of seconds. But yeah, but we know that this is already done, right? So then the question is, and we have this here, right? So we always do the no tick. But what happens when we have tick, right? Is that this, because this is already, or this function, then this is just equal to the, almost like the difference between these two things, right? And the way that I thought about it, of course, is that there are a lot of, right? Because, and basically the way that I come up with this is that I started by coming up with this first, right? So I came up with this, and how did I come up with this loop? Well, this loop is, this is just actually this for loop spread out, honestly, right? Because basically, if you start by substituting L is equal to M, then this is just equal to, this index is just equal to this thing, where L is equal to M. So I just substitute here, plus current. And current is the prefix sum here, so this is what we get here, right? So I just kind of wrote it out. And this is kind of a way, you could also do it maybe with a matrix method, but this is kind of how I wanted to think about it for this particular problem. Right, I just wanted to space it in a way that is consistent. So yeah, so you have this thing, right? And this is just this for loop in now. And then I kind of wrote it, you know, with index plus 1, and I wrote that out, right? Because this is the previous loop, right? And because we know that no tick already does this thing, so we already care about here, right? So I go, okay, well, what's the difference between these two? Well, the first thing to note is that if you're taking a max function of all these things, then we can actually take this prefix out, right? Because, you know, it's just, that's how the math works, right? Because you can take out the prefix and it won't change everything inside. The same thing for this one, right? I just thought it'll be a little bit cleaner this way. And then now, if you see it this way, then now you can see that if you kind of add the space out, then dp is just equal to, because this part is exactly the same as this part, all the way to suffix, right? this part, look at it again if you have to, because I don't know, it's tricky to me. So so yeah, so this part is exactly the same as this part. The dot dot dot, you could, so therefore you can substitute. You could substitute this with dp index plus 1 plus k left, right? And of course, now, you could do it this way, of course, right? And as a result, well, this we already do because this is literally the same as no take. Coincidentally, it is very coincidental. Actually, I don't know if I intended this part, but it doesn't even matter if you do, because then now, because even if you don't, you could just keep track of this, right? Like now, even if, because this is the way to tick, right? Of this for loop of tick. So even if you don't use the fact that this is true, then you just have this thing, right? Yeah. Yeah. Oh wait, I think I'm wrong on this. I copied and pasted the wrong thing. Sorry. Oh no, that's right. Right. The only thing that's maybe actually I think this part is a little bit no, I think I'm wrong on this one. I think this is not precisely true. And what I mean by that is that because this is not precisely true because it's max of this and this other function, right? Because this actually refers to a previous index. So I think this is technically not accurate. Though maybe it is, but I don't think you need to worry about it. Yeah. But if you take this out, then now you can just keep track of these parts in a rolling kind of way. The reason why this is actually not accurate is because this has this thing, right? So actually, actually maybe that's fine, because then now this is just equal to this plus prefix of index plus 1, right? Because that's what this thing does. Maybe that's fine. I don't know. I actually didn't do it this way, but I just wanted you to kind of see the resemblance. And as a result, you can do this with this prefix max, right? Or this is technically suffix max, but with the previous, because we know that we can just keep track. So maybe we'll play around this way. I don't know if that works, but you can also see that because of this, then now you can say that depend of some previous index. Like you could just keep track of, so previous max is going to be equal to just dp of index plus m plus some really big number from x, right? K left minus 1 plus prefix of index plus m plus 3, right? I don't think this works actually, because it actually, I don't know actually, maybe it does. Maybe there's two ways of doing it, but I didn't do it that way to solve it. But yeah, but you kind of think of it this way: prefix max is equal to max of this, and then when you move up, you just kind of also add this thingy, right? And that's how I kind of get this prefix max, is that you have index plus m, k left plus 1 plus this number, right? And because you have this number, because that's the number that's inside, so we just kind of keep track of this. And as we kind of add, prefix of max, we want to add this number for that number, right? Because basically what happened here is that I don't think I'm explaining this well, honestly, but you have some index or some other big index, right? So this is n, right? Or n minus 1. K left is equal to some number, right? Yeah, is equal to some number. So then we keep track of this, and keeping in mind that here this is exact, right? We just have to subtract this from here. So then now the previous max just allow us to kind of get what I call the suffix max, right? It gets all the way here. The dot 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 will be depicts n minus 1, k left minus 1 plus prefix of n. Maybe n, either n or n minus, I think n minus 1 actually. And maybe this is n. Yeah, I think this is n actually, right? So you have this thing, right? So actually maybe this is a better way to explain it. Sorry, friends, because this is a very difficult topic. So I just want to be precise about it. But yeah, it goes all the way down to here, right? So then now, one way to do it is that you have the previous max, and then when you have here, then now you keep track of it. And then now every time you process a new prefix of things, then this is actually just max of this previous max, right? So all this is calculated from before. So now you just have this minus prefix of index. And that's really it, because prefix of max is going to add all the previous ones from before. And that's basically how you reduce that loop into an O of 1 statement. And then now if you submit this, it will be correct. And that's pretty much it for this one. And because of that, now this is a tighter n times k instead of n times k times 2, which apparently matters a lot for this problem. And yeah, that's all I have for this one. For an upsolve, I am curious whether this would work actually, honestly. I didn't look at it this way, but maybe I can just do this. Right, so max. So here we have this function, right? But I'm not sure that this works, but you know, but that, I don't know. I'm always trying to learn different things, but because this, yeah, right. So then now maybe this is just tick is equal to, well, either this thing. So is this minus prefix of index, right? We don't. So best is equal to f max best of this, or this number plus prefix of index plus 1 minus this. Does that work? Huh. I mean, so maybe I am right. The math works both ways. Ooh, actually, maybe I'm wrong. Okay, maybe I'm wrong. Maybe there's some like weird. I don't know if this is index plus 1. It somehow was correct for those though. Can I make this work? Or am I just... I don't think this works only because there is some like weirdness with... that's why I didn't try it. I couldn't prove this correct, but I was wondering if this would work. No, I don't know. That should... feels like it should work though, honestly. And this is just one number. Because we subtracted. So the reason why I had it like this is because we subtracted this. So then here, to get all, so dp of left is equal to all, the max of the suffix max plus this. Am I just wrong? Anyway, sorry friends, I'm upsolving a little bit. Feel free to skip ahead or whatever. This is just very wrong, so I don't... Oh, I'm trying to figure out whether this... Why doesn't this work if the math kind of fits? Maybe I'm missing something on the math side. Because you have this thing, right? This is the previous number. There's no dot 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 on the top actually. I mean, I think the only thing that's a little bit awkward is that this is also equal to, technically speaking, index of k left. And I think maybe there's some wonkiness with that interaction because this is more precise. I think what I want, okay. So let me explain this again. Why? I mean, I wrote this in a little bit awkward way. I think this is actually, to be more precise, is max of this thing, right? I think I explained this a little bit awkward. So it's max of this, and of course, this thing, right? I think as a result of that, that makes it so that you cannot just directly substitute. What I should have said instead is that we can just store the inside of this. Yeah, I think maybe that's why it doesn't work, and I was just a little bit optimistic. But as a result, because of this, we can actually store the suffix sum in a similar way, right? Because we can just store this part, and maybe the way that I know that I did it with the previous max, which is much cleaner. But I think I skip a step, so that's why I want to kind of spend this time to kind of go over why. Yeah, and now I realize how I skipped a step because I was trying to prove it. And some of that being able to skip a step is because I have a lot of practice, right? What I want to write is actually something like suffix is equal to right? And this should be negative infinity, I think, actually. I wrote 0 for some reason. I don't know if this is quite right, but something like that, right? And then now we can say, yeah, instead of this, we can say suffix max is equal to of index k left, right? So then this is what we want, right? So dp is equal to this thing, but actually what we want is the suffix max, which is only the part without the dp, right? And then here we have is equal to suffix max is equal to this thing, right? Actually, no. This part is right. Yeah, and then now, so this thing you can substitute in the way that we talked about as a result, which is that this is now, this is this suffix, or you know, equivalently. Let me just write it as a separate thing. This is equal to this, right? Okay, I see. Suffix max of index plus 1 k left, right? And this is how you get this suffix max. And as a result, yeah, and we can write that out, right? So suffix is equal to f max of suffix max index plus 1 k left. Yep. Or this thing, right? dp of index plus m, k left minus 1 plus prefix of index plus m, right? So that's the suffix max. And actually, I mean, this is the suffix max, but actually, I kind of, I mean, there are a couple of ways. You could store either this or don't, but because if you store it, then yeah, I mean, I don't think it matters either way. Because you could store it or you could not store it. If you store it inside, then you just have to do some more math. So okay, so we could just not store this part. So actually I lied about this. So then we have this and this. But as a result, then now with the full substitution, then dp index k left is just equal to, as we had earlier, yeah, maybe I shouldn't have deleted it, but it looked something like this, right? And it's this minus prefix of index, right? So you have this as your DP, and of course if you have this, then you can substitute now that you have the suffix max, right? Because you know that suffix max is equal to well, maybe not. I mean, this is one of the definitions, but the other definition is this one, right? So as a result, then we can just return all this to suffix max, and that's it. And then now here, yeah, you could say and then it is suffix max of index kleft, and hopefully this is right. Suffix max is not defined. Did I not define it? Oh, I defined a suffix, not suffix max. My eyes are like getting wonky. I need to sleep. Index out of bounds, that's probably fair. Yeah. Yeah, if index plus m is less than or equal to n. I actually had that earlier, but I forgot. Current is not defined. What is current? Oh, yeah, because it's this now, so it's minus prefix of index, right? Minus is a minus, Larry. So yeah. Okay, so now hopefully this is right. Otherwise, yeah. And then the next thing to note that is that well, suffix max you only care about because suffix max you only care about x plus 1, or yeah, index plus 1 on the suffix max. DP does whatever, but suffix max, right? So as a result, you can actually optimize this space away, right? Oh, sorry. Well, no. I mean, yes. Let me actually delete this stuff now. Hopefully everyone understood. Yeah. So then the first thing to notice is that kleft you never need to change it, right? So we don't actually need kleft because we don't use any previous kleft in the suffix max, right? So actually then now we can just get rid of this, right? So actually they just do n plus 1, right? Yeah. But as a result, obviously you have to redeclare it every time, so that we could just do it here, and then we, oops. So that's one optimization that you can make, right? And yeah, let's give it a submit just to make sure that it works, and I'm not lying to you. So this is a very long involving thing. So yeah, so this works. And then the next thing to note is that suffix index is just dependent on index plus 1. So this is how we finally tied it back. Even though I kind of went really fast when I was, like, you saw me doing it live, I kind of knew this. So then this is how you kind of, you know, the previous value, and that's it. The whole optimization space optimized as well in both the dimensions, and yeah. That is all I have with this one. Let me know what you think. Thanks for watching. This is n squared or n times k. Yeah, very tiring. 40-minute explanation. My apologies during some of the weird parts, but hopefully in me kind of sounding it out, you're able to kind of figure it out, or you learn a lot, right? It's not always, you know, I mean, understanding is a key part, but also doing it yourself is key. I think, you know, this is a very tricky problem, or possibly, and I think these are the steps that, if you didn't get this problem, will enable you to get this problem. Yeah, that's all I have for this one. Let me know what you think. Thanks for again, and you could watch me solve it live during a contest now. People are done with cheating. Well, how we put 14 on Q4? All right. Let's see. I mean, we're really behind today, I suppose. K and M, return the maximum sum K non-overlapping subarrays of nums, where each subarray, okay. What does this mean? We have K non-overlapping, and M is, I mean, this is the same problem we've done recently, I think. not a big deal. I think we do need prefix sum though. This one I can see like really smart people do it very quickly. I don't know that I can, but yeah. How do I want to write this? M is 3. Oh, at least 3. Actually, maybe I'm wrong on that. At least 3 is a little bit different than 3 exactly, which is what I was thinking. So that means for each point, there's these segments. I mean, people are getting it quickly. At least M is at least 3. Can I special case that? Why is 3 so? Oh no, it's not. Well, it's 1, 2, or 3. What if it's 1? Can I special case this? If it's 1, then it's just all the same. If it's 2, I could see why it doesn't mix. Oh, at least and we could just brute force this, right? Because anything 4 can be decomposed into 2 2s, so you don't even care about it. Okay, how would I think about this, right? So if M is equal to 1, then we just return all the sum of the positive numbers. What is K again? Oh, K non-overlapping. So I forgot about K. Right. Actually, then I cannot just take the. Okay, I forgot about K actually. Is it exactly K? So it's just chunks of the contiguous stuff. K different pieces. Okay. This is going to be an annoying one. Maybe not. People are doing very fast, very quickly. I'm just being silly maybe. M is equal to 1 means that take the K largest numbers and then merge adjacent ones as we can, right? How would we do it? Alright, what does M equals 2 mean? 2 means that when M is equal to 3 is interesting. Is it? Is it DP? What would DP look like? Maybe it's not prefix sum. I misread the K part or something. Or M part even. So then if we have DP, what would that look like? We would have current index with M left and then with K left, right? And that is M. Okay, maybe that's fine. Because that's 2000 squared times 2 or something. Maybe a little bit slow, honestly, but I don't know. So we start 0, we have k left, we have m for m left, right? So then now if index is equal to n, then if we are done with k, then we're done, so we're Gucci. If we're not done with k, then if k left is equal to 1, no, well, m left is a little bit weird, right? So okay, so query, if this is the case, then we're 0. If we have m left, then return -1 or minimum or negative infinity. Otherwise, no, wait. If k left is equal to 1 and m left, well, okay. If this is the case, then we can just return go of index, which is n. We just end the streak, right? So if m left is equal to 0, then we can end the streak here. So then we go to k left minus 1, so 0. No. How do we have to define the states, Larry? Okay. So then, all right, we'll write the base case later. I think I have to depend on how I want to write this, and I'm not quite sure yet, apparently. Okay, best is equal to negative infinity, and then now we want to say, okay, so we want to start. Okay, so if m left is greater than 0, then we actually have to start. So okay, this is 0 actually. Then we have to keep going, right? So then we can do best is equal to have to keep going, so that's index plus 1, k left remains the same, n left minus 1, and plus num sub index. Okay. Okay. Otherwise, then we can either stop. I think I needed one more variable. I think that's why I'm a little bit confused. Maybe something like ongoing. Oh, can start, maybe. Okay, so that part is fine. Otherwise, if we can start a new thing, then yeah, we start a new thing. M is the thing, right? Plus num sub index on this index. Otherwise, is it can start? No, it's can continue maybe. Well, we do this anyway, because we always are able to start a new one if a debt is paid. Otherwise, we can continue, then this is just this stays the same. This should be m left is equal to 0, so that stays the same. And then we can also just skip, right? But then you cannot continue, right? So this is can continue. K left, true. Whatever, this is false. This is to start a new one, so maybe it is true. Yeah, because this is continuing, so this is true. Otherwise, this is false, and we skip. This is technically false, actually, or it should be false because this is. And then I think this is roughly right. But the states are kind of expensive, we'll see. Oh, I forgot to define the thing. Okay, so then now we can say if there's m left, okay, yeah. Because we have to keep going. Otherwise, if there's none left, then this is also good. No. I think everything else is just negative. Maybe I'm just wrong. Maybe that's the only case. Yeah, maybe that's fine. Well, it's not the right answer though, so that's not Gucci. I don't even know. I mean, I know how to debug it. It's just I don't know how a quick way to debug it, which is not great. And this is never true, so that's probably a bad sign. Oh. So if we start a new one, then let's just call it true then as the default. Maybe that's a better way of doing it. Still wrong, but I don't know if it's closer. 12. How would you get 12 even if you wanted to? Maybe added these three. Zero to 2 is 4. 0 index of 2 left. Okay, so that's just the base case. And here we go to 1 1 because we started a new one, right? M is equal to 2. Oh no, m is wrong. That's why. This should be m minus 1 because we start with one number. Okay, that's why. Now is it fast enough? I don't know. I don't even know what's a good way to test this, but that's not good, but 2000 by 1000 is already too slow. Seven seconds is not acceptable. Though it is right, the answer's right, but I don't get it. Why is this so slow? Are these inputs correct? try in Java. Let's go result. I'm not confident about the Python version at all, honestly. That's why I'm like back to Leetcode being stupid. Compiler error. Does that get rid of the compiler? Nope. Line 7. I was in the driver. Should this be an int? Is it supposed to be an int? I guess so, actually. Maybe it's fine. Yeah, I mean it is, but is this fast enough? I don't know. What is a way to do it? Nums is equal to 2000 elements. I don't even know how to do it in Java. Oh, I can do this. Okay. Alright, this is too slow. The end is wrong, so that's good that it's wrong. Right? Why would it be wrong though? Am I doing it wrong? I hate that I solved the problem and I'm trying to do stupid things. Because Leetcode is silly. Why is this so wrong though? Should be not that. 20,000 maybe? Is it because this number is whatever? Oh. Yeah, okay, that's why. But why would that be the case? Is it just, I don't know, 2,000 numbers, right? Memo. Why? Negative infinity. There's some weird stuff here. I hate the time. There should be like 20,000 or something, but why? To keep going. I mean, lucky I didn't submit it, because that would cost 5 minutes, but what? Okay, so if K isn't that big, it's fine. Maybe? What is K? That's good that this is wrong, because I don't get it, but actually, why did I get two different answers? If I define M and K and array. Oh, because of the length. I think okay, I'm just being dumb then. Okay, I mean, okay, I think I figured it out. Okay, so at least it's okay. I mean, it seems fast enough. I don't know, is it right? We'll see. Is it timeout? Ooh, wrong answer. That's even worse. Does this give me the right answer in Python? I print out stuff, which is actually not great. Expected 41, so something with the Java one is well, which is actually really annoying. Yeah, because I don't know what was changed about the code. And this looks like it would time out, so but I'm gonna YOLO submit because I don't know. I have to figure out why it's not the same, and it's gonna time out. I hate Leetcode. It's gonna time out. Yeah. But why is this 51? Nothing changed, right? What is the difference between these two codes? Nums. Is there some like weird thing going on? I hate that I'm spending time on this. 51? Why is it 51? Well, what is so different about these two codes? Oh man, I can't believe I'm wasting so much time on this. Because Leetcode cannot handle Python. Memo is fine, probably. K nums oh, M012. No, M is what is going on? That's actually bad. I don't know why M is only 2. 0, 1. Actually, I guess that's right. M is at most 3, so that's not actually an issue. But why is it? Why? What is going on? What is wrong with this? Index n, negative infinity, cache. Oh, there's no M in it. You gotta be kidding me. I didn't even check. I can't believe. I mean, it happens, I suppose. That is actually really. At least it's right-ish. Okay, now it's right. We don't need the main. I don't know if the main does anything funky on Leetcode, so that's kind of funny that it just forgot the mlef. If it still times out, then okay. At least it's kind of tough to figure out why. Because okay, let's keep track of the Python one. We're really behind. How many people got Q4? A lot of people, so I'm just gonna lose points today. But yeah, it's 2000 times 2000. Why is that too slow? Times 3 maybe, so maybe it's not fast, but I don't know that it should be slow. And unfortunately I had to eat a wrong answer and 2 time limit exceeded. That's not great. How can I optimize this faster? I don't know how much more I can optimize. Prefix sum, we don't need prefix sum. Well, we could get rid of this maybe. I don't know that that's much faster though. Maybe just for maybe on the allocation of memory. Maybe that's fair. I have to think of all the cases again, but it's still very annoying. Maybe I could have done it this way, I suppose. Okay, so then now. Okay, we don't have to keep going ever. We want to either start a new streak. Right, if we start a new streak, then we have to do index plus m plus so continue being true. Okay. Continue the previous one. Okay, that's actually fine. And then we just don't do a new. Yep, okay. Everything looks good except for this one. We have to actually get prefix sum of index plus m minus prefix sum of index. Something like that, right? Oh, and I guess no. I guess I forgot about the case of if index plus m is less than or equal to n. 13. I wish I had the other case that I have. Do I? Nope. Would this have it on here? Oh. Yep, it has my extra wrong answer case, so at least I can test for it. Is this fast enough now? Still don't know, honestly. Alright, let's. 1000, right? Something like that. Still looks too slow. 2000, true force should be fast enough. I don't know. That's the thing, right? Is that I don't know how to optimize for this, or rather, like I don't know if this optimization is going to be fast enough, right? Apparently, maybe not. What if I convert it to Java? Also, I can't believe it. I mean, I could believe it. But like complexity wise, this is the same, so I don't know. Like even if it's good enough, it's hard to tell. Right. No wrong answers, but it's gonna time out, I guess. Huh, how am I gonna, That's the thing, is that you can never know with Leetcode, so now it's a disaster. I don't know. What else to say or do? This is 4 million times 2. 4 million times 2 is not a big number. I don't know why they don't work. Do I come back to it? can't even get Java to work. That part is actually surprising. And I don't know that top-down would be any more helpful. Or bottoms up. At this point, I might as well just do it in Java, but what I want to do though, well, the answers are just wrong. I mean, I could debug this, but this is wrong anyway. I don't know. Use index. M can be more than that, right? Oh wait, we don't even use M anymore, so 0, 1, 2. Okay, yeah, that's right. That's why I was confused before. Right. Where do I have my, what's it called? I mean, this is pretty fast, honestly, right? It's just that I don't know what they want from the inputs, so it makes it very awkward. Let's try again. See, like, this is so stupid. That's not even like a problem solving thing. I spent like 5 wrong answers and I don't know, right? And a lot of time to debug it. But all right, well, let's just try to enjoy the rest of this contest, because I don't know, I gotta stop doing these contests because the code is dumb, honestly. But okay, which made it even worse, just because, yeah, I mean, I had to convert it to Java. I don't know why this was too slow. Did people have a that's the silly thing, is that it's not even fun to kind of like try to learn. Oh wait, I did need this one. It's not even fun to it's not even fun to try to learn from the top people, because this is just all ChatGPT on top. Leetcode is, I know Leetcode is a real person, at least. Okay, I mean, bottoms up, I guess, is the way to go. I was going to actually, let me see if I can convert this to bottoms up in Python. What? No. But I mean, I don't know. It's just not very fun, because like this is, it's now getting to a point where we're just having these issues every contest, right? Well, this is just way wrong, so okay. That's not right? Even I knew that. Maybe k-1. I don't know why ChatGPT is dumb on it, but let's see. Maybe wrong anyway, or maybe even too slow. I don't know. But like, wrong answer is fine, I guess. Some of it is just because I'm too lazy to actually write the bottoms up. I guess I could have written the bottoms up. Alright, what was my bottoms up code? Okay, so this is my bottoms up code, so we can rewrite it, right? DP times was it n? I guess 2 can continue. For k plus 1. Right, and then we have we'll go backwards, I guess, for index and range from n, right, for k left in range from, doesn't matter, k plus 1, and for can continue in 2, whatever, right? If index is equal to n, if k left is equal to 0, then dp sub index k left can continue is equal to 0. Maybe we could even write just res, else res is equal to negative infinity, right? dp is equal to res, we continue. Otherwise, res is equal to negative infinity, or maybe even best you could write it, whatever. If index plus m, then we have this thing, right? It's actually really not that hard to write, but I don't know. It's just that during the contest, it's really hard to figure out whether you need to write this or not, right? I mean, this is very easy to write, right? Well, it's very easy to write because you already written it. That's my point. Right, and then now we just want max of dp, n, no, not n, 0 in this case because we went backwards. We want k, and then we just want max of, I guess it should be 0 actually, right? Oh no, we don't use m, we use continue, so it's just, yeah, okay, fine. Something like this, right? I still don't know if this is fast enough or even right, but because Leetcode is silly. I mean, how else would you do it in Python? Am I missing an optimization? Maybe I am missing optimization. Am I missing a base case? Is it supposed to be wrong? Like in my original thing? Oh, whoops, not this one. Oh, I guess this is in Java, that's why. This is still in Java. Where's my last Python one? Just want to make sure that, you know, that my original code is right so that I don't have to double check it. Okay, so that is right. I'm returning the wrong answer here for some reason. Am I not propagating the k left stuff? Index plus 1, index plus m. Index going down should be right. Right? Yeah. Maybe something like that. I don't know. I didn't think that would change it, but I'm just wasn't sure. Even though I confused the true force stuff anyway. But maybe it should have been like just to keep it more consistent, even though it doesn't change anything. K left. Did I miss some? This, I mean, this should be when its K left is greater than, you go to 0. Huh. Why was this? Oh. That's actually bad. Maybe that's why. That's why I was reaching more states than intended. So, okay, so that's actually my fault. Maybe in the Java version it doesn't fix it. I mean, it seems like it still times out, so it is what it is. But okay, so this is a little bit better, but clearly still wrong, even though, yeah, that's pretty bad actually. I think that's why. I mean, it's still timed out anyway because Leetcode is Leetcode and Leetcode hates people. But I mean, I guess we can also still like write another thing of K left is equal to 0, then we just return 0 because we cannot start anymore anyway. So that eliminates some stuff, but it still may time out. Oh. That's actually pretty good. But I don't know if this helps enough. Apparently not. I mean, I guess not. It only kind of limits here. But I don't know why the bottoms up one is wrong still. That's pretty bad though. May even be why the Java version is timed out before. I do wonder. Like, I don't... what does this mean? Oh, it's K plus 1. Wow, I didn't even look at what the Java version did. Is this the working code? Huh, I didn't even look at what it did, but I guess it just did from K0 to K, which is technically symmetric and correct, but that is actually not what I wrote, so ChatGPT is kind of sketchy again. So the top-down version works, but the bottoms-up version is not working. Dun, dun, dun. I mean, this has to be at least this, so I guess there's no reason for it to be infinity or negative infinity. But why is this wrong? What am I wrong for? Am I getting all the things? 0, K, subtracting. Am I going out of bounds? K plus M is less than or equal to N, so we should go N. Just don't know why this is wrong. Well, we want only 1 and I have 22. How do I even get 22? 16 is the expected answer because it's these two. How do I get 22? Okay, this is a 3-dimensional thing, so it's just so hard to read. Right. Clicked on submit by accident. I mean, luckily this is not the contest, so I don't care. But now it's making me wait to run code. Yeah, no Sherlock Holmes. Okay, 16 and 22. What does 22 mean? That we can, so that's a 1 that could continue. Oh, this is always 0. There's no, because then now I get a boost. Okay, so that's actually a bad, not a base case, but kicking off, because you can't continue from the 0, 1. Okay, that's just me being dumb then. I got confused by the earlier code, but it still times out. I don't know why. Is there an auto optimization I can make? Yeah, I mean, okay, let's see. Alright, I mean, this is probably ChatGPT, but as you can see, increasing substitution. I mean, this loop is the same as mine, right? Maybe? Their loop looks even worse, honestly. So why is their loop better than mine? I don't get it. Everyone is ChatGPTing. This is ridiculous. But like everyone has this loop that is so like I don't know how people get this to pass. Am I confusing things? This is left, right. Isn't that what I had? Yeah, no. Am I clicking the right one? Maybe I clicked on the wrong one. Oh, I clicked on the wrong problem, that's why. I was like so confused. Okay. That's better then. Okay. I mean, it's still ChatGPT, but at least I was getting confused about the constraints. Okay, so K and N. What is M? I mean, I guess this is faster, but I don't even understand this one. Actually, I was thinking about doing it this way, but I didn't think that I could. I guess if you do it this way, the idea is that you have this prefix something. But that's kind of the same, that is the way that I have here, right? And we still have timeout. And this only adds 2x work. I don't get why it would be. I mean, we're just looking at ChatGPT code. This isn't even like, you know, useful. It's just, yeah, is this a cheater? I don't know. J times M. This is a weird code. I mean, I don't know. Like maybe it's understandable, but the way that they do prefix sum is crazy to me. Actually, I think I get it, but I feel like I think I get what they're doing is way different than the way that I'm doing it. I don't know why. Leetcode is just stupid. Like at most, I'm doing 2x work, so I don't know. It's still n times k, right? So the only problem with here is that yeah, maybe I need to figure out how to. The thing is that I need to skip impossible states, maybe. But either way, Like, I see how they kind of figure it out. It's just like skipping X numbers, right? And then the prefix sum is just the sum over the thing over a bit. But like this works in Java, so I don't know. Like I don't know that I trust people who did it this way, frankly. Well, I mean, this one literally has, you know, comments, including option 1. Like, at least we're gonna cheat, try to make it like a little bit respectable, right? So many cheaters. I mean, and all the code looks the same, so so it's just the same idea. Maybe there's just no way to do it the way that I'm doing it because it is a little bit more difficult. And here you can take advantage of M, apparently. Like this is an extra very difficult step, but a step that like, okay, I don't know. I'm not even learning from trying to read the code because every code is the same, which is the ChatGPT one. I feel like this is the more natural way of writing it for sure. But I just can't get it to work in Python. In Java it worked, even if the code is a little bit wonky. But what is the running time in Java anyway? Yeah, I mean this is fast enough. And I had to remove one indexes. That part is fine to optimize, but I don't know if I can do this in Python. Like I just can't get this to work. This one. Yeah, I mean I should have gotten Q4. Well, I don't know. I mean, it is what it is. Should I have gotten it? I mean, I had that idea, but I just didn't know how to prove it correct. Eh. I mean, the only other thing I can think of is no, but then you allocate the memory, right? So it doesn't like I wanted to do something like this, right? And then you know, if dp index k and but I don't even know if that is good enough. There's no cache clear anymore. Like, because you still allocate the memory. I think that's the problem. Even if not all the states are possible. I think a lot of the states are possible in this one anyway. So I don't know. Like the constraints could have been 1,000 and it would be much easier. I don't know why they insist on being silly. Yeah, I don't know. I think today may be my last day. I'm just between the ChatGPT and the cheating and stuff like that. I am done with Leetcode. Maybe at least the contests. It's just not fun or reasonable. Like I had to spend. I don't even know how long I spent because the problem wasn't that hard, and I, you know. And then on the meanwhile, in the same case, Q4 you can use. That's not Q4. But in the same case, Q4 people just did it with, like, you could do it with regular strings and it's fine apparently. Because this is n squared things. I don't know that you could create a counter case on it, but it's just useless. What a weird problem. QT, I don't know that I can do any more. Like, I feel like I've given my all with respect to wanting to do it. Like I don't know if there's any more optimizations on this one that I can do without understanding it differently, which is just ridiculous, right? Because other people are not required to, and in fact most people just ChatGPT it, so it's even sillier, right? Yeah, I don't know how else to write this. And I don't know if anyone else would have written it, but because you can't even see it on the leaderboard because everyone just does ChatGPT, right? Like I mean, you know, I don't know even know that. Like, I don't know that I can blame Leetcode for ChatGPT, but it's just not useful, right? Like, everyone's doing it this way, and I don't think this way is intuitive at all, right? Maybe it is. I don't know. Maybe. But I feel like I should be able to do it my way without, you know, without being penalized for it. Like everyone did it this way, which is just ridiculous. I don't believe that at all. Oh, I mean, maybe there is a selection bias in that no one can do it my way. And if no one could do it my way, then, you know, like this is all ridiculous. Then that's why, yeah. If no one could do it my way, that's why I'm not seeing solutions where people did it my way, right? Everyone did it that prefix some way, and I probably could figure that out, but I just, you know, it's just, Like, I don't think that's the natural way to think about this one necessarily, unless I'm wrong. I don't know. Maybe I'm wrong, but I still feel like my way, like it's like this is k times n, right? Like if it's k times n, why is my k times n that much slower? Can I optimize this more? I don't know. I mean, we still have 6 test cases, which is silly, right? Like what is this case? How long does it take my answer? Four seconds. And if we didn't have half of this, say, is it that much faster? Yeah. I just want to see the performance. That's why I'm not caring about it. The answer per se. Like this makes it like half as fast or whatever. But it's still I don't know. I mean, you could see that it makes it way faster, but I guess that's the difference, right? It's just 2 times too slow. At least in Python. I'm sick of these guessing games, so I don't know. It's just not very fun for me. Because there's no way for me to know. There's no solution for this. Everyone is doing n times k. I can't even guess how to do it necessarily. I mean, n times k times 2. They could have easily made n equal to 1,000, and this would have been very easy to do. Right? Like maybe you convert k left into k used or something, and then start from, you know. So here maybe we can actually, let's see if we can change the order real quick. Yeah, I mean, I expect this to be slow still. I just want to see if it's correct still. Should be, but relatively soon it should be. Right? And then once you do that, then now you can start to index a little bit, because you can remove some impossible states, but that's a way unnecessary optimization, right? Because basically it's n, n is 0 is fine. How do we do it? Okay, so maybe we do k used instead, right? If k used is equal to k, then we're Gucci. So we start at 0, right? Plus 1, you go to k, right? Okay, so is this still the same thing? Nope. Oh, because now it has to be now it has to go from this. Maybe? No, shouldn't matter actually. Actually, maybe it does. Okay, let's give it a quick submit. It should still time out, right? But now we can do something like the states are not possible, so maybe here we do negative infinity as a default, right? That should still not change the answer. We just don't get weird things. And then now, what is impossible, right? Impossible states, we start at n, right? But we want to say minus k used times m. I don't think that's should change that much. Nope. Plus 1 maybe? Am I off by 1? No, but why is this wrong? We start at going backwards is a little tricky. Maybe my math is wrong. Oh, because I don't set the things. But if k uses k, then this doesn't do anything, right? K uses 0, then we start at n. Okay, if k uses 1. It should be right. Why is this giving me big negative infinity numbers? Is this even faster? I mean, it should be faster, but is it fast enough for me to even try to fix? It's a little bit fast. It's actually a good amount faster, but it is still wrong. So, okay. So let's see if I could fix it. Then, I mean, maybe it is just enough fast enough. K used is 0. If k used is 1, then right, so we have 7 seconds. Running it without it is 5.69. So we save a lot of time, but it is a little bit wrong. It's because this returns a big number instead of, right? Okay, so 0, okay, so if it's 1 used, oh, because 1, well, so if k use has to be at k at the end, so it's actually maybe minus k minus k used times m, something like that, something weird. A little bit faster, as you can see. Let's give it a quick submit. I don't know if this is fast enough, but that's such a tough optimization to make, even if it's right. I mean, it's not tough. It's just that it's tough to say that that is enough, right? And apparently, even faster is not enough. It just saved for one more case. So I don't know how to solve this, right? Like, apparently the way to solve this is just ask ChatGPT. I mean, I don't know. Like, is it that much slower than, say, this one? With the cheating thing? Apparently. So mine was 7 seconds. This is 1 second. Wow. Why is this so much faster? K plus... I mean, I know that does a little bit less work, but... like, why? I'm trying to understand. Is it this n times... I mean, it's still k times n, right? I mean, I know, like, we kind of mimic that. Like, we have some max functions here, but I don't get it. Like, what? Is it just because this is 2x? No, but that's 7 to 1 seconds, right? Why is this so much slower? TP, it's fine. Prefix sum, we did, right? Web sum, whatever R and whatever is. I mean, this is definitely fewer operations, but I don't know. Yeah, let's just say instead of this web, so we can get rid of this. I don't know if that's that much better, but it definitely doesn't hurt. That was 7 seconds before. Yeah, okay, so actually that helped a lot. So even just something silly like that, but so I guess maybe it is just what it is. It's just that these things are just really slow. Right? Like if I would have, like, is this lambda function getting slow? It is crazy though. I wouldn't have expected it. Is this faster? From 7 seconds. It is more for like my future learning stuff, so it is faster, so I still need to do that then. I thought that maybe if I use this fmax function is faster, and it is faster, but it's not fast enough. I mean, we still need like 5 probably max cases, so this is probably still going to be too slow, right? It is still faster. We'll give it a YOLO submit. Still probably too slow, because just like this thing. How would we think about this? And maybe that's how they, I mean, yeah, right? Did I get more inputs? No? Okay, fine. Yeah, how? Like, why is this so much faster? Is it really just this thing? I mean, we can get rid of one of these, I suppose. So index of 0 to n. dp of index of k 0 is equal to equals to 0. And that's it, right? So then now we could skip to n. No, I think it's using this one, that's why it lies. That's actually kind of funny. I was like, wow, that is suddenly very fast. And again, we shaved more time to it though. This is just wrong. So we do shave time, but it is wrong, so that's not a great trade-off. what is this? NK index is equal to n. Why is that different? Yeah, so this would be equal to 0, which is a good base case. We have negative infinity for the rest. So this shouldn't change. Why is that? And even you just use max. I'll keep this in here for now. Why? And k used is equal to k, otherwise, yeah, I mean, what if we just ignore this then? But that's already in here. I don't get it. I'm so confused. Why can we skip this? Because k used is 0. Why? I can't even make this optimization today. Why is this? Okay, so this is right, but that's... Am I misunderstanding this? Can continue is... right? K is... What if I just don't do this? And I just do this? Right? Still right. So the only thing that happens is if index is equal to n, right? So, okay. For index in n, all right? So then why can we just like not skip one number then? K uses k. K can continue in 0 and 1 is equal to 0. Okay. I don't get it. My code is so bad today. Yeah, I don't know why though. Okay, fine. If I could just write if this is equal to infinity or something. Like, what is this updating that I am not? Then what is it? Index is equal to n. I mean, I guess the rest is the problem. So it is just that we want to skip n when k is equal to 0. But that doesn't even, that shouldn't matter that much anyway, but... Because the negative one is the issue when k used is... Yeah, I guess that's why it's wrong. So we can actually remove this, I suppose. I guess that's the only thing that makes it a little bit... you can even just skip this, right? right? So we made it a little bit faster. But yeah, I don't know. It's still crazy to me though that, yeah. I mean, I'm just, I mean, this is ChatGPT, so it's not even his code, so I don't even know how to feel about it. There's still time limit, that's fine. So I have this code, but like, why is this so much slower? Like 1.1 second versus whatever. Is it just allocation of can continue? Can I get rid of can continue? How would I get rid of this if I wanted to? So if the two, I mean, maybe that's what this thing does, but it's still ridiculous that we need it, but only in Python, right? Because in Java it's fine. So we have to kind of guess the issue a little bit. And I'm not 100% sure. I mean, I guess this is probably what I'm trying to do, but I don't see it quite yet. Basically, if can continue is a 1, then skip this. Okay, well, I just want to see how much faster it is if we just eliminate one branch, right? My watch is telling me to get up. Yeah, it's too late. So it saves some time, but this is still too slow. But how? Why? Is it just, so how much of the time is just allocating memory? Right? I guess so. Do they allocate memory in a good way? No, they do everything. So it's not even that. Well, not just that anyway. Is that faster? I mean, that's just a long bit. I'm trying to see if it does no work. Like structurally, I don't get how this is like so much slower. Why am I doing that so much slower? Is it just access? Is it because I'm using too much memory that we're missing cache all the time? Is that why? That's the part that I'm just confused about a little bit. 2 is inner thing. I mean, unless it's something silly like we should. That would be funny if that's the case. That I needed to swap this and. Am I like just missing a lot of cache? Is that why? I don't think so. You should always, right? Like why does this take 5 seconds? Are you kidding me? Wow. I got some stuff to learn, I guess. I mean, that's fine. That's actually really wonky. I have to think, I guess I am just hitting a lot of cache misses. I mean, that's actually pretty cool to learn. And something to kind of think about in the future. But That's crazy. Do I even need this anymore? Maybe, hopefully. I need both those optimizations, which is ridiculous though. Because even without it, this is still very slow. Oops. This is very slow. So I needed this thing, which I guess fine, but I'm just gonna YOLO submit. Just it's not even YOLO submit. It doesn't really matter anymore. But I'm just curious. Huh. But this took so many optimizations, right? And why is that chunk of memory? Yeah, actually, this was very close, but I definitely still need this optimization, which is ridiculous. So, how long does this even take? It's not internal average, just waiting. 6 seconds still. Today I learned. Maybe I'm just for science. Because that's not the way that I'm more natural with, but because for me it's always just depends on the order of the thing, but I have a race in like 7 hours. But that didn't matter. Why did the 0 and the 1 matter? Oh, I see. Oh, I think I see. It's in the memory allocation. Actually, that is actually a bit faster. But the reason why is because oh, that is crazy. I was focusing on this part, but I think it is because of this part. Huh. I mean, this is crazy. I mean, I think my initial intuition was that you have memory mem cache issue, but that's not the case. I think it's just memory allocation things, right? Let me see if I could do a playground thing. Right? I don't know what this is. Probably was just debugging someone else's code, but that is crazy. Actually, that is a good thing to kind of try in the future, though. Okay, good. Whatever, it doesn't really matter for this one, so okay. How do I run? Oh, one codes there. 9.6 seconds. Okay. And then how do I run another one? I mean, I could just write this, I think. It just, the other thing doesn't really matter. That is sloppy, see? Because it's running 2 million memory allocation arrays. So it's not even the access, but it's just because of this. That is crazy. So I mean, today I learned something. So it's something that I have to be mindful about in the future. I don't think it matters in Java. How is my Java allocated? So there's 2. I do wonder if this, I mean, so okay, so I'm just curious what it looks like in Java. Okay, so we give a submit, right? Just to kind of establish baseline. Okay. I guess I don't even need to. I could just do it here, right? So let's say we have just just copy paste here. All right, so we have this. We don't get rid of the prefix. Get rid of this. One code. Whatever, just to kind of stress test it. It doesn't have to be related to the thing. So this is actually pretty slow, right? But if I rewrote this as, actually I don't have to rewrite that much. I just put 2 on the front and plus 1 on the bottom. And it's so much faster, even in Java. How much of it is fluctuation? I don't know, right? Okay, so ran a couple of times. Is it within that range? Just to be clear, right? Because the expensive part is calling something like fill. So actually, I'm curious whether my first Java code would have worked, right? So I did have a TLE on Java. What form is this? Is this one? Yes, I have a TLE here. And the reason why I had TLE is, why do I have a TLE here? I forget. No, I actually did forget. What is the difference between these two? I wish there's a diff thing. Oh, it's just tops down and bottoms up. So okay, so could I have done it bottoms up if I had done it correctly? Or if I just done if I just moved the 2 here, and then yeah, and then this is just what the index 5 out of bounds, which is probably fair. Oh, I thought I pasted this. There we go. May still be out of bounds actually, because oh wait, no, maybe not. Maybe it still times out though. Okay, well, I was hoping that that would be a little bit faster. This one is 618 out of 624. This one is 6. Okay, so that didn't change that much, actually. But it definitely adds up. I guess it's just still too slow. Top down. Why would it be? I'm trying so hard to learn about all these problem things. You know, this looks what I want, and it is definitely slower, right? Just converting it. Yeah, it is definitely like slower by, and this is just one input, right? So so we save time here, but we don't save time, or we don't save enough time, right? So we can look at our AC Java code. So this is our AC Java code, right? Which we don't have to do a lot of the optimizations we did, by the way. So even then, Java maybe is the way to go, right? Just give it a quick submit. just to kind of establish baseline again, right? Okay, so then now what would happen if we convert this one to reindex, right? So that we have 2 here instead. So then that means this code doesn't make any sense to me actually. Or maybe it does, but it's not the way that I would have written. Like this is push, but I wrote it pull, right? That's actually crazy that it works, honestly. Dynamic programming is kind of crazy, I suppose. Oh, I mean, ChatGPT is crazy. I mean, I guess this is also crazy, but in general, wasn't this working before? Did I miss a spot? Yeah, I did miss a spot. Okay, is this faster? I should accept. Yep. Like, is this a general rule that I have to do now? Yeah, so much faster, right? Huh. Because the expensive part of this is not the filling, it is the calling of the function. Huh. I thought there's some memory locality thing, but not on the initialization, right? I mean, there is some on the initialization, but maybe there's, I mean, no, I mean, there is definitely some maybe like fragmented data and cache locality stuff, but we tested this, right? So it gets dominated by this fill. That's crazy. I didn't know that. I mean, you know, you could always learn, I suppose. Let me try to do this in C++. I'm curious. Because I'm curious whether this is like universal. Like, I honestly just didn't know it, which is crazy to me. This is, I don't know if this includes compiling, but I don't know. I guess we'll see. Did I miss the prevent? Oh. I guess I missed the prevent, but I don't. What are you doing? Please, I want to go to sleep soon. Oh, there's a comma here. That's why. But the error was doing something funky. So it's also true in C++, huh? I think someone was telling me about this, but I thought they were talking about memory locality stuff, and not this thing. Huh. Today I learned, I guess. I mean, it's still Leetcode 4 because I still, in Python I would still have to make some optimization, but now I have another thing that I have to realize. Alright, and I think this is a very particular case because there's a lot of, because we're doing because in 3 dimension we're doing 4 million memory allocations versus 4,000, right? So the overhead of that just kind of adds up. So if you even put 2 here, it should be fine, right? So it's just like, it has to be not the smallest number if my idea is right. Yeah. So you have, okay. I mean, it doesn't come up that much, or shouldn't come up that much, but it's interesting to think about. But also, like in Leetcode, it still would have taken me forever to fix, because I still would have had to do, like, this is ridiculous. And Q4, so I'm here to upsolve yet again the Q3, The thing is that I think I was a little bit the funny thing about this problem and this upsolving, and I just kind of a little bit hint on my Discord, is because I think I accidentally made an optimization without even realizing it. I think what I mean by that is I'm gonna go over it real quickly, and then kind of just reviewing it, right? So initially I had something like this is what I had, right? But even here I I don't know if I would call it accidentally, but unintentionally did the M left and the can continue thing, right? So I already kind of did it this way. But actually the more naive way of thinking about it is actually something like this, right? So we don't actually need them. We can just say something like yeah, so then here if we kind of look at just this example, right? Actually, maybe we don't even need this anymore. We'll rewrite it a little bit later. So if we wrote it in terms of just index and k left, then yeah, then what would the DP look like? Well, the thing is that then now you have to choose a length of between m and I guess all the way up to n or something. I don't know. I mean, it probably won't go to n. It's like n minus index or something, right? So then now it means that we want the max over, or the sum, something like this, right? So current is equal to 0. Current we added by num sub something like this. Actually, this would be sum of index all the way to index plus m, right? Because it has to be at least m. And of course, you could. The way that I would think about it is that you start with this, but of course, so this is the tick. So okay, let's rewrite this as tick, no tick, right? So no tick. No tick is a little bit straightforward. It's just equal to, so it's actually the best part. We can actually put it here is what I mean, which is index plus 1, k left, right? And then the tick is actually, yeah, and then here, of course, this is just prefix sum, right? So we can just do index plus m minus prefix of m. Of course, we have to double check that index plus m is less than or equal to n first, right? So this is just taking exactly m. So here we do max of best, go index plus m, k left minus 1, right? And also we want to maybe just say with k left is equal to 0, we just return 0 because then we're just done with taking arrays anyway, right? So we have something like this. We did the prefix sum, right? Plus current. And then now we want to extend the prefix sum, or prefix, we want to extend it, right? So you could also actually just do the math. I mean, we're doing a rolling sum. So maybe that's actually not as necessary, to be honest. Maybe we can just write current is equal to index plus L for the length, right? And then best is equal to this, right? And that's it, I think. This should time out, of course, but I want to make sure that I get the right answer first. This should time out because this is n times k, which is already 4,000, and then here we have another m loop or n loop, so that's going to be way too slow, right? But let's actually get this right first. Yeah, am I missing by 1? I don't know if I'm off by 1 here. That's why. M left is not found. Where's M left? Oh, here. Yeah, I mean, if k left is 0, we already returned 0. So that means if we go to n, then we already negative infinity. Okay. Not quite right. Am I off by 1? It is possible that I'm off by 1. And oh yeah, I guess this is actually, I need to do, this goes first. Okay, I mean it's wrong, but that's okay. How do you even get 18 from here? Even if we want to, we can't, right? So that's kind of weird. But oh, this is not M, this is index, that's why. Okay, so easy fix, right? L is the length, should be at least M. Am I doing anything wrong otherwise? Oh, no, this is not plus M, this is plus L. Again, another copy and paste typo. So okay, so it looks okay. I expect this to time out, but this is how I want to write it, right? And the funny thing is that because of this, oh, well, negative infinity, that's actually kind of awkward. K1. So this is 0, 1. Actually, I need to debug this. That's what happens when you upsolve, I suppose. So we want to tick. So no tick is fine, but we want to tick. Then L is equal to M. N plus 1 maybe? We definitely want to take, because M is 1, so it goes to 1. Yeah, okay. L is length. That's a very awkward one though. I put it in there. But is that enough to fix it? L can be N inclusive, I suppose, to do the entire thing. Yeah, okay, fine. But this should time out, right? The reason is because, like I said, this is N times 2000 times 2000, another N loop, right? And then now we can convert this to top down, right? How do I do it? Yeah, whatever, yeah. So now we can convert this to top down, and the way that we convert to top down, maybe something like dp is equal to just say negative infinity times whatever k plus 1 for n plus 1, right? And the base case we have left is equal to 0, so we have yeah. Yeah, so so we have index, it doesn't really matter, but as long as it's equal to 0, right? So for index in range of n, if we have k left is equal to 0, then we're good. So that's the base case. And then everything else is just for index in range from, I don't know, let's just go to n for k left in range going to k plus 1 for the inclusiveness. Then now we just take kind of this thing here, right? And then dp of index k left is equal to best, and that should be good. We want dp of 0k, right? Again, this is still too slow, right? Because this is n, k, and m, but I just want to make sure that this works real quick. Let's go. Oh yeah, I knew I forgot to random place. Right? Yeah. We'll say if k left is, oh, because we wrote the k left is equal to 0, we return. So yeah, so this has to be k left is greater than 1, right? Actually, yeah, this will be greater than 1 because we could skip all the k left is equal to 0. Okay, right? Do I still have a go? Oh, whoops. Pretty straightforward, right? So far, except for it being wrong part. Index. Oh yeah. Okay. So it goes backwards. So we run them like this instead. yeah, no, this is fine-ish. No, we want n plus 1, so this is actually n plus 1, and this is fine, yeah. Index plus 1, index should be n minus 1, okay, fine. Alright, I think this is maybe right, let's double check, right? Like I said, this should still time out, right? N times k times this, right? But the key thing to know about the way that we wrote it this time is that here, what does this look like? This looks like that because best is just equal to this thing or this loop, right? And then the question is, can you get rid of this loop, right? And actually we can get rid of this if statement, I think, because it just implicitly just skips it from here, right? But now what we're saying is okay, so this is the tricky part, right? Is that we want to draw it out. I'm not going to draw this out here, but, and I'm upsolving it right now, so the explanation part may be a little bit different, but yeah, let me see. So maybe I won't explain it that deeply. I'll explain it during the explanation part. But okay, so current is equal to this, right? So then we want to get max over all of these for L is from M to N plus 1, right? So that means that we want to get max. So if we look at this as a subarray, we actually want to get max of, yeah. So then maybe the tricky thing is that you want this, it only looks at k left minus 1. So actually, as a result, we can actually alternate these without, I don't think, any changes. Okay, making sure that we have time limit still. Right. This is still time limit. And then now we can look at only, because we only care about k minus 1 and I guess this thing, which is fine, easy lookup. K minus 1, that means that we can keep track of all the previous things that are in a sliding window kind of way, right? Because then now we have dp index plus how do I even explain it or even write it first, right? It's just that, okay, actually, this is fine, or this is how I want to preserve it, and I want to open another window so that the explanation is a little bit cleaner. Okay, so I have, let me double check my things for explanation purposes. Okay, so then I have this, but then now we want to, for the previous thing, so then maybe you have something like previous is equal to, previous max is equal to 0, right? And then, so ignoring the current for now because it's a little bit tricky, then now the new element, so then now we're trying to figure out, you know, so we have, this is what we care about, but this is actually, but this looks at from dp index plus m k left, right? So max of something like this, max of this, ignoring the other things for now, right? With the current, we have something like this. Oh, this is -1, right? And so forth, right? And then keeping in mind though, the previous index that we did is index +1. So the previous index that we did is index +1, and that is just equal to this number or this number, but this is actually smaller because index +1 here means that is this +1, 2, 3, right? Dot dot dot. Well, actually this is it, right? And then the dot dot dots here. So that means that going from here to here, we have the transition of just an additional number of here, plus is this number plus, and now we're trying to figure out the current part, right? Yeah, so how would this look like? So this number is going to be so this is plus prefix of, let's just write it out, plus m +1 minus prefix of index, right? And this is the case here, right? And as a result, this is also just prefix of index plus m minus prefix of index, right? Yeah. And actually, we want to write this for here as well, just to write it out. Minus prefix of index +1. I think that's right, right? Yeah. Right, so we're trying to kind of convert these things, right? The thing that you can notice is that going from here to here, well, you have to recalculate this number. That's fine. That's an easy one operation. But then the max of all these other numbers, well, we can line them up a little bit, right? So let's take this out, and then we have this, right? So that means that going from here to here means, and keeping in mind that for the max function, all right, let me step back for a second. For the max function, you can actually take this out, right? As in, you can take this out of the max and take it outside the max, so it's this, right? And same thing for here. So then now everything is identical, except for, everything is identical up to except for this number or this row in general, and you can add that, right? So that's really the idea here. So then the previous max is equal to dp well, we started at 0, right? And then now the newest number is just going to be index plus m, right? So tick. So if index plus m is less than or equal to n, I think, then we consider this chunk, right? Plus m, k left -1 plus prefix of index plus m. So that is, we want to update max to that, right? And then now here, I'm going to open another window just because I'm going to have to explain this. Sorry, friends. Now you see how the gravy is made. Maybe. What? What did I do? Oh. But then now I can take this. Oop. Okay, so then now I have this, and then yeah, and then now I could get rid of this loop, because then now it's just this previous max minus prefix of index, right? I mean, maybe I'm off by 1 or something, but that's the general idea. Maybe I'm off by a lot even, but that, I think that is roughly the general idea. I have to I think I'm maybe writing this part incorrectly, but oh yeah, I mean I didn't update previous max. Oh, I deleted that if statement by accident. That's why. Okay, I mean, so this looks good. The -10, not so much. I don't know if it's because maybe this has to be negative infinity. Okay, so that is actually true. Let's give a quick submit. I mean, if it times out, that's fine. It's just that with its wrong answer, that is a problem. Actually, I do know how to explain this, but yeah, it told me I don't get it. But yeah, this is basically it. Wow. And the funny thing is, because the reason why I didn't come up with it is because I did a premature optimization from the get-go. If I didn't do this premature optimization, I would have maybe been able to see it. It's still not a easy thing though, but it's doable, just not easy. But yeah, that is all I have for this one again. So thanks for watching, and you could, I mean, I think this is the end of the live portion, so yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, these contests, everything in between. Yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.